Our next speaker, Miodrag Vladic, is co-founder and lead software engineer at Answers, and he will address the capabilities and limitations of large language models like Bard, GPT, and Claude, especially in potentially replacing search engines. He will introduce a unique method using source frontier from information retrieval to enhance LLM's accuracy and source validation, utilizing billions of vectorized text segments. Miodrag, please welcome.
Thank you, Zoran. Hi, everyone. Thank you for coming. I'm really glad to be here. My name is Miodrag Vladic, and I'm a co-founder of Answers. And in this technical and business talk, I will talk about influence of large language models on today's search engine industry, and also I will provide you insights into our achievements in Answers in this field. So first, briefly about myself. Back in 2019, I joined the NLP research group of School of Computing, and our goal was to develop a question answering system for open domain questions that requires factual answers. And in the first year, we managed to develop base technology and had a system with about 100,000 answers. In meanwhile, we grew to the Answers startup, and 4 years fast forward, we managed to develop a system of tens of billions of vectors, which is basically order of magnitude scale of Google. Also, we managed to integrate a large language model into our source frontier, actually our information retrieval system. It's all thanks to our brilliant team of young Serbian researchers. So probably no one would believe that such system can be built from someone besides big tech companies. Also, I'm a part of the Answers sister startup Kagi, where we work on an AI system which works with causes and effects. And we believe the first step and base of general intelligence is to make a system that resonates and works with causal relationships. To describe a large language model in one sentence, it could be said that it's basically a system that predicts next token or the next word based on the previous word. And it's a system that is fed with a lot of text data to catch patterns in order to understand language and generate it. Today there are popular products from large language model as Google's Bard, OpenAI, GPT, and new players in the game are, for example, Claude and Mistral AI. This technology makes astonishing results for the tasks like generating content for copywriting or schoolwork or essays for the schoolwork, also making code scripts and helping developers debug the code, even making discussions about scientific hypotheses. And their results are usually hardly indistinguishable from text written by human. But the main task in order to replace search engines would be retrieving factual information. As you can see on this picture, usually these language models makes mistakes, so-called hallucinations, and it's always important to consider checking for important information. The main thing for making large language models to replace search engines, they need to have strong innate knowledge, and also as users of the search engine used to have sources to validate information they get and to see the wider context. Here is one table that is published by Vectara company on their GitHub, which is hallucination leaderboard, where you can see that the model with least hallucination, it seems to be GPT-4, and one with most hallucination is Google's Palm model, which belongs to the family of models that Google's product Bard uses. The reason why is pretty unlikely that Google will replace their search engine with that product Bard did not of technical nature, but the business nature. It's hardly to imagine that Google would let Bard overtake or cannibalize product of their search engine and endanger then hundreds of billions of dollars worth the business model of advertising through the search engine. Also, Mistral AI published the benchmark results on their model and showed that they overperformed the best Meta's Llama model in almost every task, but in the knowledge, as you can see on these plots, which confirms how challenging and what is kryptonite innate knowledge represents for the large language models. ChatGPT is incredibly limited, but good enough at some things to create a misleading impression of greatness. Confirmation of this stance is made by nobody but Sam Altman himself, CEO of OpenAI, or former CEO of OpenAI. According to this morning news, maybe he will be future CEO of OpenAI. Anyway, our solution for this problem of hallucinations in large language models is our YOT-Answer source frontier. So what is it? Source frontier is basically information retrieval system which have tens of billions of answers that are collected from all over the internet. Our technology is built from scratch, so we don't use some external services as API results of Google or Bing. Also, it's really scalable for incremental building in comparison to retraining and fine-tuning large language models to expand their knowledge. It's a pretty interpretable and controllable pipeline technology, so every part of the system is intelligently connected with each other from filtering sources through segmenting texts, embedding these text segments and ranking in the runtime system. So this model is this makes us easier to correct mistakes and spot weaknesses in the system. It's pretty lightweight. It can be run on one or two servers. It depends on the preferable response time for the system of tens of billions of answers. It's important to mention that it retrieves various answers, and for every answer, it also gives a lot of sources, multiple sources for validation. Currently, it's updated until May 2023. We are planning to launch a new version next week, which is be updated to the data until October this year. So here's one example of results of our source frontier for the query, what is superconductivity. You can see here that for shown 3 answers, every answer have multiple sources where this answer or very similar answer occurred on the internet. So you can validate correctness of given information. So what is the role of large language model in this system? Basically, it summarizes and generates one unique one unique smart answer based on the facts given from the source frontier. And it's important to mention to not be mistaken with the classical RAG or retrieval argumented generation. The key difference is that source frontier give more atomic facts or direct answers in comparison to RAG, where usually it uses whole documents where there is more freedom for large language model to hallucinate. The system is not intended for the chat or generating texts. It's only focused on retrieving factual information. The LLM inference works in a way that that gets source frontier answers and put it as an input in model as context along with the prompt and query. We fine-tune our model using, for now, about 10,000 examples. Some of them are manually labeled, but most of these labeled data for training are bootstrapped from the larger model using Yota answer source frontier in order to avoid hallucinations in these labeled answers. This is one example of Yota answer smart answer. And here you can see that every part of the generated answer have the source link which from it get facts in order to generate this answer. This is the demonstration of superiority of combination of these two technologies. Here in this example, you can see that actually source frontier didn't do a perfect job with ranking, but although this LLM managed to handle that and ignore irrelevant answers and generate the best answer possible. Also, in other way around, source frontier supports large language model with facts and fill the gaps in innate knowledge to avoid hallucinations. So the main advantage of this technology is first low cost and low time of the implementation, which gives this great potential for profitability in comparison, for example, with GPT, where initial cost of training was over $100 million, and also for customized training, for example, like for Bloomberg GPT, this customization of models could take several months of training and a couple millions of dollars cost. This technology is pretty interpretable, as said before, in comparison to large language models, black boxes, and also it's really scalable for incremental building. It took only a couple days to expand knowledge of data with hundreds of millions of sources. And the most important thing, this combination of technology avoid hallucination in language model answers. Only mistakes could be made by source frontier wrong informations, but there are multiple sources for validation this data. So based on all this, you can imagine what power of this system could achieve with 1 or 2 order of magnitude larger amount of labeled answers to hundreds of thousands or million labeled answers, and with source frontier with 100 billion answers. This now seems for us pretty achievable goal to achieve through the next year. That's it. Thank you for your attention. If you have any questions.
Any questions? Oh, sorry, here, just get the microphone.
Yeah, hi, thank you for the talk. I was wondering when the LLM generates this answer based on the source frontier database and so on, I've noticed that it kind of references the correct source which it used. Is this something that's part of the generation process of the LLM, or is it kind of added ad hoc, like to which the LLM actually attributes its answer to, if that makes sense?
It's actually an additional feature. That sources didn't recognized by LLM itself, but there is a comparison between generated text and answer from source frontier to actually spot which part of generated answer is actually from which source.
Okay, thank you.
Hi. First of all, this is great that you're doing work for sourcing the answers, and which I'm very fond of, and I think everyone should do more. However, I was wondering for the validation part, still there is a human in the loop to validate, right? So
sure.
how would it look like if you run the code somehow, if you put it in production and it's being served as a simple chatbot or something like that for someone who wants to find information, but you just put it for your customers or whatever. So how sure you are, is there a mechanism in your code that ensures the answers besides these citations?
It's give to the user to actually validate. That's why we provide multiple answers and multiple sources. So we want to avoid products like these commercial LLM products that just make convincing, sometimes convincing answers, even when they are made up. So we leave to the user to validate himself the correctness of the results.
Okay, but
does that?
Yeah, it answers. But in the end, maybe the next level of the autonomy is something that you would like to consider based on all these answers. Can you give something genuine that you know that's already validated because you read it from source or something like that?
That's ranking for basically to rank answers. The algorithm actually does that to rank the answers by the possibility which one is more seems to be correct. And also LLM generates its answer by also they are weighted by the ranks. So.
And my last question, great, thanks for the answer, is how do you intend to label 1 million of examples, or if you go for some higher volume of that?
Like said, we partly this maybe the most quality labels are manually labeled, but most of them we plan to collect more questions and do inference with larger open APIs of large language models, and using our source frontier in order to avoid hallucinations to actually get that, to achieve that 1 million labels.
Okay, thanks for the answers.
Any other question? I don't see any hands, but help me if you... Oh, yes, sorry.
Thank you. So just one question as a follow-up to this one. If you're going to use LLM like GPT-4 or something for synthetic data in combination with source frontier in order to avoid hallucination, why aren't you just in production use GPT-4 with source frontier?
It's because it's incomparably more cheap for running, and also it's a lot smaller model, and it takes a lot less resources.
Okay, thank you.
Okay. If there are no more questions, I will thank Miodrag for his presentation, and I'll give you a certificate
Thank you.
for being on Data Science Conference.